Time is 6 1. I'll wait for 2 more minutes so that students can join, and I'll start the session. I think I'm audible and my slide is visible. I will wait for 1 more minute and then I'll start the session. I think my screen is visible and I am audible. If you guys have any doubt, you can put it in the chat box. Someone has raised the hand, I think. If you have any doubt, please put it in the chat box. Okay, then I will start the session. I think my PPT is visible. Okay. Hello all, my name is Shriyari. This is the NPTEL problem solving session for the course Advances in Welding and Joining Technologies. And the course instructor is Professor Rubag, and myself, I am being a teaching assistant for this course. This is the 8th and last live session for this course. Today I will be discussing the 7th assignment for last year and this year's assignment, and also 8th assignment, last year's 8th assignment. Since this year's 8th assignment is yet to be, deadline is not yet over, so I'll be discussing only last year's 8th assignment. Okay, I'll start this session. First of all, in this welding of non-metals is basically, it's completely theory based, where there is straightforward, and there is no First of all, in welding of non-metals, basically they are straightforward by and explained by sir. So I will be mainly concentrating. So like sixth assignment, seventh assignment, this year's and last year's, I will be just going through the answers and little explanation. And also for on the eighth assignment, last year's eighth assignment, I will be discussing. So before that, I wanted to show some few videos which I have taken the CWJ and from YouTube only. For the sake of better understanding, I will be showing some videos also. Okay, I will start with this. As you know, okay, in modes of metal transfer, basically in GMA uh, there are two types of welding, like in arc welding, autogenous welding, and other is deposition welding. In autogenous welding, like gas metal arc welding or plasma welding, where there won't be any deposition of like where there is only melting of electrode, there will be arc will be generated between the base plate and the arc will be generated between the base plate and the electrode, and arc will be there. And so because of the heat generated due to the arc, the base plate will be melted. If the thickness is high, then we used to use some kind of filler. If this is the arc and yeah, this is arc and this is the plate, I will be feeding external filler wire to deposit. This is GTAW or pulse autogenous welding, where there is no any deposition. But whereas in a deposition welding, like metal inert gas welding, MIG welding, and also in submerged arc welding and submerged arc welding and shielded metal arc welding, there the electrode itself will, once the arc is generated, this is a consumable electrode. The electrode will melt and will deposit. But here, the how the metal is transferred from the uh, electrode to the base plate is very important thing. Based on very important characteristics, based on that characteristic only suitable mode of metal transfer is used for 3D additive manufacturing for basically wire arc additive manufacturing process. So in the class, sir has discussed about globular mode and also then spray mode, then also short circuiting mode, and finally he said that and finally he concluded about CMT welding and its advantages. And now, first of all, globular mode, there will be arc length will be more and current will be more than the short circuiting mode and less than the spray transfer mode. However, the arc length is more, but the current is not like the the droplet generated and the current is not greater than the spray mode. Here surface tension will be more, so droplet won't be detaching. So droplet will grow once the gravitational force, because of the gravitational force, once the gravitational force becomes more than the surface tension force, the droplet will be detached. In globular mode, the droplet will grow. It will be bigger than the wire. Once the once it get grown, then it will be detached because of the gravitational force is dominating than the uh, surface tension force, which is the attaching force. Basically, surface tension force is the attaching force. So first of all, we'll see globular mode. So initially arc is generated, and basically I wanted to tell one more thing. This is on high speed arc images where the frequency can be ranging from 20,000 hertz. Means in a 1 second they will be capturing around 20,000 images of a arc. Welding will be happening with the help of high speed camera. They will be capturing around 20,000 images per second. Per second, that's why it's called high speed camera. Maybe 10,000 hertz, that may be changing, but it's in terms of like 5,000 hertz or 20,000 hertz, something like that. The images will be captured in that frequency. Means in 1 second, we will be capturing around 20,000 images, and that will be used as the analyzing. So first, I will be showing globular mode. So arc is generated. Since the arc length is more and current is also very less, the droplet is formed, but it is not detaching because current is less compared to spray transfer. So droplet is formed. So once the here you can see it, right. The droplet is growing more than this, and gravitational force will be more, so it will be detaching. I will be showing one more time. basically I wanted you guys to understand with like video. That's why I wanted to show you the video. So the droplet is growing. Once the gravitational force is more than the surface tension force, it is detaching. But here the big droplet is detaching. No, so that's why sometimes we'll observe spatter and all. Uh, so the here like very high current is there. This is in spray transfer. The current is more. So because of that electromagnetic force will be more. So because of that detaching will be happening. Surface tension will decrease. Since current is more means temperature will be raising more. So once the temperature is there, surface tension will reduce. Because of that detaching is happening. This you can observe, right? So spray of less than almost less than the wire diameter, the droplet is forming and it is detaching. This is called spray transformer. uh, One more time I will showcase. So the arc is formed, and once the current, since current is very high, the droplet will be forming and it will be detaching because at higher temperature, surface tension will be reducing, and so attaching force is less. So it is detaching, and so you can even in these figures, you guys can see these patterns. See, you can observe these patterns also. See. So this is spray transfer. One more compared to both here a spray and globular heat input will be more compared to short circuiting. So generally short circuiting is preferred in GMAW based on application, but in additive manufacturing heat input will be less, right? Because we are depositing many very large big components, especially if we go for wire arc manufacturing. So in spray transfer, what happens? If you see in uh, what is this globular transfer, the arc length is very high, but in short circuiting the arc length is less and also current is less, so droplet is forming but surface tension is more. So it is not detaching, but droplet gets in contact with the droplet gets contact with the base plate. See, it's getting contacted. It touches, the electronics are designed such a way that the feedback loop will be sent, so that the electrons are designed such a way that once the droplet touches to the base plate, the current will be increased, and so short circuiting is happening, voltage will be zero, current will be increasing. So because of that, surface tension is getting reduced, so detaching is happening. It is touching and current will be increased, so detaching is happening. Even you can in short circuiting, though heat input is less, because we are increasing the current, because of the more pinch forces, spatters are observed. I play one more time short circuiting now. So it is short circuiting. Once it short circuits, current is increased. Intentionally current is increased, the electronics are designed such a way, current is increased, so detaching is happening. I think you guys understood. So this is a globular mode, spray mode, and short circuiting. But next to researchers, what they did was they developed this cold metal transfer. Cold metal transfer in the sense, basically it's kind of short circuiting only. But here during short circuiting, what happens in uh, suppose this is a base plate and this is my electrode and this is droplet, short circuit, right? During short circuiting, what happens? They intentionally increase the current to detach the droplet. However, in cold metal transfer, what they do, during like once the short circuiting is happening, the electrode is retracted. The electrode is retracted. So because of that, because of the retraction force, and liquid fracture will happen, and droplet will be detached. And droplet will be detached. You can see, I will play one more time. You can see here the electrode will be continuously fed, and there is no retraction of the, there is no any retraction of the electrode in globular spray or conventional GMAW. You can see here the electrode is feeding is fed through the rollers, and it is melting and it is doing. There is no any retraction of the electrode in globular spray also. The electrode will be fed and it is melting, and it is droplet is transferring. This is spray. And also now we'll see about Now short circuiting will come. Here also continuous fed, there is no any retraction. The droplet is from it detaching. Electrode will be continuously fed through the electrode is continuously fed, and droplet is forming and detaching. There is no any retraction. In short circuiting, the advantage of short circuiting is it's a lower current, so heat input is less compared to other thing. But however, spatters are observed. Fronius has developed cold metal transfer. So I'll be discussing the cold metal transfer in a short while. So these are the three modes of transfer. I hope you guys don't have any doubts. Rest of the things as I said earlier, the welding of plastics or like non-metals are clearly explained in the first lecture. So I'll be explaining less about that. I'll be mainly focusing on. Okay. So additive manufacturing, it's also called 3D printing. Basically it's called for rapid prototyping. So the main concept here is like, if I go for subtractive machining, suppose if I want to manufacture a sphere, you can see in the left, suppose if I want to manufacture a sphere, I'll take highlighter or pen so that it will be visible. Okay, yeah, suppose I want to manufacture a sphere. Conventionally what we'll do, either we'll go for machining or meta machining means I will take a block. From that block I will carve out the unwanted material, and I will get the sphere. That is metal cutting or machining process, right? uh, One more other process is like forming, means forging and all, where what I can do is like I will take the block of metal block and I will hit it, I will apply the compressive forces with a hammer, whether it may be a closed die forming, closed die forging or open die forging. I will hit it with a hammer, I will get the sphere. That is one more other process. uh, Other thing is like casting, where we'll make the mold, and after making the mold we'll spray the molten metal into the mold and we'll get the required shape. That is the conventionally manufacturing process. But however, in converse to that, in additive manufacturing what happens is I will give a CAD model, and the CAD model is sliced. Basically it will be deposited layer by layer. If you can see in this figure explains like, suppose if I going for removing the material, suppose I have a block, I will remove the material and I will get the sphere. This is one kind of thing. However, but material wastage will be there, and also recycling will be sometimes it will be difficult for some kind of materials, some kind of and some costlier materials like titanium. It is very very costly, so material wastage will be there. So if I want to deposit a sphere in additive manufacturing, what we'll be doing is like we'll be depositing layer by layer from bottom to top. Like I will be depositing first layer, second layer, third layer, and layer by layer I will be depositing to get the component. This is the additive manufacturing. And this figure one explains the like process chain of additive manufacturing. Like basically from the CAD software I will get the CAD model. Once the CAD model I will convert into STL. STL means triangulated faces. That is basically used to get this. When once I slice the STL file, I'll get the contour. So once the STL file is done, it is sliced in the AM software, and once this AM someone has raised the hand. If you have any doubt, please put it in the chat box. If you have any doubt, please put it in the chat box. Okay, I think it's enabled. I think chat box. Yeah, you can send chat messages. Okay, I'll wait for 2 more seconds. If I don't get any reply, I'll proceed further. You can put it in the chat box. Okay, anyway. So once the STL file is generated, it is sent to the once the STL file is generated, it is sent to the AM software where slicing is like based on the basically reorientation is happening. so that less support structures are required. That much is not in depth is not required. So once they send to the AM software, reorientation based on the design of additive manufacturing principles, reorientation is happening. Once the reorientation is done, slicing will be there. Basically, slicing is done to convert the 3D into 2D slices. The 2D slices, based on the 2D slice information, a toolpath will be generated. Once the toolpath is generated, it is sent to the 3D printer. In the 3D printer, the deposition, if it is powder based, then powder material will be there. If it is like some kind of liquid based, then kind liquid will be there. Or if it is like solid, like wire based, wire will be the feedstock. So based on that material is fed, and based on the tool path and material and process parameters are set accordingly in the 3D printer, the deposition will be happening. Once the we will get the completed part. This completed part sometimes needs to be post processed, and also inspection needs to be done. This is the process AM process workchain. I think I made it clear. Okay, so I will go further. As I explained, spray transfer globular mode, and one more thing, one more spray globular and short circuiting mode, right? And also researchers has developed cold metal transfer. Basically, it's developed Fronius cold metal transfer. Because of that, and also GMAW setup compared to the other metal additive manufacturing process like powder based uh, equipment and all. Whether if I'm using laser as a power source or electron beam power source, those are actually costly, and also manufacturing of powder is very costly. Uh, Hence, wire arc additive manufacturing process is developed. Basically, wire arc additive manufacturing is a process. It is basically GMAW process is customized for using wire arc additive manufacturing process. That is the thing. So, like if I take powder based manufacturing powder itself, sometimes it is very costly, and also handling of powder is costly, and also equipment is costly. Regarding assignment 6, I think some mail has they have sent some mail regarding the update. Please check it. Okay, at last, if time permits, I will check it. Today we are discussing 7th and 8th assignment. If any modifications are there, I think they have earlier also they sent mail. I don't know what 6th assignment. Okay. Where I was. Yeah, powder handling is also difficult. So because of the advent of cold metal transfer, where the heat input is decreased compared, basically cold metal transfer means the name cold metal they have given is it's a relative term compared to the other conventional GMAW process in CMT cold metal transfer. The heat input is less. That's why they kept cold metal transfer. So, uh, wire arc additive manufacturing is developed to manufacture medium to large size components with medium complexity thing. I will show the video of. I will show the video of cold metal transfer, and also wire arc additive manufacturing. Means wire arc additive manufacturing is customization of GMAW process, where in general cold metal CMT mode is used for deposition. Uh, I will show this. Okay. So this is a GMW torch. So deposition is happening. Basically here, based on the CAD, here the CAD model is pipe. So circular thing is deposition. Like you will get to know the idea once the so some kind of pipe is depositing. So first layer is depositing here. It is started from here and it is depositing like this, and it is going like this. So first layer is deposited. So simultaneously second layer is deposited. It is actually the here the video is speeding up. So this is the so layer by layer deposition is there, and GMW torch is used, and base plate will be there. So deposition layer by layer. Uh, so you can easily get the medium to large size components with medium complexity in wire curtain manufacturing. Suppose if I want to manufacture very highly complex and small parts, generally we call for powder based metal additive manufacturing techniques. So here this is how the uh, in this left video this shows the wire curtain manufacturing for printing a pipe. Okay, I'll play one more time. This is about wire cut. Unfortunately, okay. Here you can see the metal transfer mode. You can observe there is a retraction of electrode. See. So basically, arc is formed and droplet will grow, and so once the droplet is contacting, retraction is happening. Because of the retraction, the like fracture happens at the liquid molten pool, and droplet is getting discharged. So compared to the spray mode, the droplet transfer is easier here. Means heat input is less compared to the spray like short circuiting thing. In this figure, the like retraction is happening and arc is formed. Droplet is short circuiting happens, but once short circuiting happens, no, the arc is getting the electrode is getting retracted. So this is the cold metal transfer thing and wire hacker to manufacturing. Okay. So if suppose this scheme figure 2 shows the GMAW based AM process, basically it's called wire to manufacturing process. Here this is the GMAW touch. I will be here linear wall is depositing. So I will be depositing layer by layer. After each layer, the electrode height will be increased, or the work the work flat or work table is decreased, and deposition is happening layer by layer. This is the schematic of GMW process. It is kind of similar to it's a basically GMW process customized for GMW process. Sorry, customized for wire pattern manufacturing process. Now, okay, we are running out of time. Okay, this figure 3 shows the arc behavior in a typical CMT process. In the last, you saw the video, right? Basically, 1 to 4 is the like 1 to 6 is the peak phase, and 6 to 8 is the background phase, and 8 to till here it is a short circuiting phase. During this arcing phase, during 1 to 6 this is the arcing phase. You can see, right, these are the in this figure these are the arc images captured high speed and particular high speed arc images captured and shown in this left figure. So 1 to 3 you can see there is a growing of arc, means arc is forming. Once the arc is formed from 3 to 4, you can observe the arc intensity is increased and also droplet is formed. Here you can see, right, the droplet is formed here, something like this. The droplet is formed and arc intensity is also increased from 3 to 4. And from 4 to 8, intensity of arc is reducing. However the droplet is maintained. After 8, short circuiting happens. During short circuiting, obviously there won't be any arc, so we are not able to see. So at the short circuit, the base plate it will touch the droplet will touch the base plate, and it retracts back, and again this 1 to 8 cycle will form. This is about the CMT cold metal transfer process. I think I made it clear. Okay, we will soon we will finish this also. So first 20 questions will be like from the assignment 7, and last 10 questions will be the assignment 8 of last year. Which one of the following welding process used for joining of thermoplastics? Submerged arc welding is for metal thing. Gas metal arc is also for metal. Explosive is also used for in general for metal only. It's already discussed, I think, in something like second week or third week. Third week, I guess. In solid state welding and all. So yeah, friction stir welding is the answer. Then the next question: which one of the following statement is not pertaining to ultrasonic welding process? Welding cycles about 1 second. Yeah, this is also true. Amplitude of vibration is in microns only. Something. So 0.05 mm. Yeah, that is also true. And frequency of vibration in the ultrasonic frequency. So C is also true. Basically, it is ultrasonic welding process in plastic welding is mainly used for amorphous material. It's discussed in SIR's class. So D is the answer. 2D is the answer. Yeah. Uh, Match the column A with column B. So laser transmission welding, laser transmission is basically used for dissimilar welding between metals and plastics. It can be used. Uh, Metal and plastics can be used. Brazing economical process can be. This is an economical process which can be used for ceramics. So A to B3. Then ultrasonic welding. Ultrasonic welding. It can be used for plastics. Yeah. Then ultra short pulse laser welding is used for high transparent material. So A4 B1. So 3A is the answer. Yeah. Next, which one of the following joining process is similar to spin welding process? Spin welding process means there will be a uh, circular or any material, plastic material to be joined, and for that one more circular thing will be rotating, and it will be given axial displacement, and pressure is applied. Because of that friction, heat will be generated. Uh, Heat will be generated, and weld bead is formed during after cooling. So this is the spin welding process. Yeah. So ultrasonic welding process. But basically, ultrasonic welding means ultrasonic frequency vibration needs to be there. Vibration welding also not the case. We have because so friction welding, spin welding, some kind of frictional forces will be there. So 4C is the answer. Then glass welding is also not the thing. So which of the following welding process combinations suitable for dissimilar join of plastic and metals? Okay, the difference between what is the question? Difference between vibration and ultrasonic welding. Basically, both the electrode will both will like vibration will be there. Here, the frequency of vibration is the main thing. In ultrasonic welding, it will be around 20,000 like 20,000 hertz in the ultrasonic frequency range. The frequency of vibration is more in ultrasonic welding compared to vibration. That is the main difference. Okay. Uh, Next, where were we? Yeah, I think fifth one only. Which of basically mechanism of joining same in the sense like due to the vibration and there will be a frictional heat is generated and during frictional heat is generated and softening of the plastic or like softening is getting or melting of the metal is not melting, softening of the material is happening, and during cooling the joining is happening. You can say that basically the frequency range is different in ultrasonic. Basically friction is the main thing. Frictional heating is the main mechanism of joining. Which of the following welding process combination suitable for dissimilar joining of plastic and metal? Electron beam no, vibration no, laser beam welding and resistant welding. Yeah, both can be used. 3 and 4. So C. Yeah, correct. Which of the following statements are true regarding vibration of vibration welding? Yeah, just now I discussed like here the vibration is like 100 to 500 hertz frequency of vibration, but in ultrasonic the vibration is around 20,000 something like that, more than that even in the ultrasonic frequency range. That's the main difference. Which of the following statements are true regarding the vibration welding? Welding cycle is very short about, yeah, it's true. And frequency of vibration is also correct. Amplitude of vibrations is around, that's also correct. Yeah, here amplitude is more, and there it will be in the very less. You can see in this, right? Amplitude is very less. Here the in vibration thing amplitude will be more. So this is 3 also correct, and use it for joining polymers. Yeah, it is used. So yeah, 6B is the answer. Which one of the following welding process refers to dielectric welding process? This is straightforward. Radio frequency welding. We are running out of time. Yeah. Which one of the following statement is not correct about short ultra short pulse laser welding? Ultra first, yeah, it's in the femtoseconds or picosecond. Yeah, so it is very fast, and energy per pulse is in nanojoule to millijoule. Yeah, that is also correct. C is the answer. Yeah, yeah, C is the correct answer. Average power, it's in the range of 100 watts, but he has given 1000 watts, so this is not correct. And the pulse repetition is varying up to 100 megahertz. Yeah, that is also correct. So it's the extremely high powers in ultrasound can be achieved by this yttrium, like aluminum garnet thing. This 9D actually it's discussed in the class. So you can go through that. And then which of the following, still 20 questions are there. Okay. Which of the following statements are pertaining to laser transmission welding? Yeah, fast cycle time, that is correct. Precise energy control, that is also possible. High mechanical stress, no, mechanical stress will be less, and better welds are achieved. So 10A is the answer. Now 11th question. Match the following process, following thing: ultrasonic welding and ultrasonic welding. Yeah, vibration creates local heating. The one D is the thing, and okay, basically C. Yeah. Uh, then radio frequency welding. It is like direct dielectric hysteric losses will be happening because current fluctuation and all. So 2C, 1B, 2C. Then glass welding, oxy gas torch or furnace heating can be used. 3A, and spin welding is for friction heating. So basically 11C. 11C is the answer. Then fill in the blanks in the sentences mentioned below by selecting appropriate word. In the glass welding process occurs. Obviously, it needs to be above the glass transition range, means melting range of the glass. Above the glass transition range, once the fusion of the parts completed, they are cooled very slowly. Because if it is very fast, means brittle kind of solid will be formed. Brittle kind of this thing will be formed and cracks will be there. So very slowly, basically it is very slowly it is cooled to relieve the internal stresses generated by the thermal gradient. So for 12th one, above very slowly relieve. I think 12B is the answer. Yeah, 12B is the answer. Then choose the correct welding process among the following that can be used to weld ceramics. Basically, ceramics will be having high temperature sustainability, right? So, high energy beam welding can be used. So, laser beam welding is used. Electron beam welding can also be used, and also friction welding is also used. Even diffusion welding is also used, discussed by sir. Yeah, 13A is the answer. But for ceramics, economical way is brazing. 14th one, the transfer. Identify the true and false statements. The transparent upper part is required for laser transmission welding process. Yeah, in laser transmission welding, the upper material should be transparent, so laser will be uh, traveled, and below plate should be absorbing, so that at the interface heating will be happening and joining will be taking place. And the lead glass needs to be heated at a higher temperature compared to quartz glass of welding. Basically, lead glass is less weldable, like temperature is around 870 degrees Celsius, and for quartz it's around 1600, I think 1600. It's mentioned in the slide. So this one is false. 14th one. Welding of ceramic can be done most by brazing. Yeah, this is correct. And by resistant welding with strength near to parent material. This is also correct. So already it's all discussed in research lectures. So 14, only second statement is false. So I think 14B is the answer. Which of the following processes cannot be used to join metal to plastic? Radio frequency welding cannot be used. Laser beam welding is used. And resistance welding is also used. Actually, it's not. I doubt like ultra short pulse laser welding is not. I am. Yeah, 15D is the answer. But if you see in search video, resistance welding is also used. Can be used. So this question I think needs to be checked. If you check the search slides, resistance welding also is there. Okay, we will proceed for next question. Then the friction welding process is similar to which welding process in terms of heat generation? Spin welding process. It's already discussed. Yeah, 16C. Then in ultra short pulse laser welding uses ultra short pulses of extremely high power density for extremely short period of time to join force. As a result of heat affected area is very less. So I think 17A is the answer. Yeah, 17A is the answer. Which of the following statements are correct for laser transmission welding? Laser is aimed at the transmission, right? Transparent plate will be there. Below that, absorbent will be there. Once the laser transmission is fed, it should be transparent, and at the interface it should be absorbed. So laser is aimed at the interface of the two plastic vessels. Yeah, this is correct. Uh, then lower surface should be absorbing light to create heat. Yeah, that is also correct. 1 and 2 is correct. Any type of plastic can be joined irrespective of its chemical compatibility. No, no, no. Chemical compatibility should be there, because melting point of both metals should be in the same range, so that joining can be done. But clamping force is also required, but here it is not required. So 18C is the answer. Which this is straightforward. 19th one. Basically, this is the main takeaway point from the 7th lecture, right? Which phenomena during cooling cross-linking of the polymer of molecules will happen in polymer welding, right? Sorry, plastic welding. Which phenomena are involved in the thermoplastic welding process? 19D is the answer. Cross-linking of the polymer molecules. 19D. Then, which of the following welding techniques is also referred to as dielectric welding? In last year's thing also, yeah, radio frequency welding. Same question is repeated. 20A is the answer. So this ends the assignment 7. Since today is the last class, I will be discussing both assignment 7 and assignment 8. Uh, uh, till 20 questions. I discussed last year's first 10 questions or from last year's assignment question, and this next 10 questions were from this year's assignment question of 7th, week 7. Then I will be from here. I will be discussing about. I will be discussing about last year's assignment 8 question. This year assignment 8 question I can't discuss because you guys need to the deadline is not yet finished, right? And today is the last class, so I will be discussing this also. Okay, I need to finish it in a hurry. Okay. Which of the following additive manufacturing technology is used to sinter polymer coated metallic powder? Basically, it's like sintering process. For metallic, it's like powder bed fusion process. So 21B is the answer. Selective laser sintering. Selective laser melting in the sense complete full melting up will be happening. That is it both are powder bed fusion only. And digital light processing in the sense in this figure, in the second figure, you can see, right, this is VAT photopolymerization, also called as stereolithography process. Here there will be a photopolymer resin. This yellow color is the photopolymer resin. Based on the tool path, this laser will move. Once the laser is moving, what happens? The photopolymer resin, due to the laser, it gets solidified. Means it gets cured. Once the laser is transfer, wherever the laser is moving, it gets cured and gets solidified. It gets solidified, right? So based on the tool path, the laser will be moving. Once the laser it gets solidified, this platform will be decreased. So once the one layer of deposition is completed, platform will be decreased, and again the laser will be traveling accordingly. That is called VAT photopolymerization, or also called as stereolithography. This digital light processing in the sense, if the beam is like kind of projected beam, then it is called digital, similar to VAT photopolymerization only, but projected laser beam is used means then it is called digital light processing. Jetting system in the sense, basically what happens in binder jetting process, there will be a, here it is liquid in digital light processing or VAT photopolymerization. This process, like powder bed fusion or binder jetting, basically there will be a powder. After each layer deposition, the powder will be fed like this. The roller will give the powder. Because of time constraint, I can't able to explain every in detail. Okay. After one layer deposition, this platform will get down and the powder will be there. And inkjet, like binder jetting in the sense, the binder is through the nozzle, the binder is supplied here. So the wherever the binder is there, the powder particles will get bonded, and according to the like tool path, the binder will be moved. So for 21, B is the answer. 21B is the answer. Okay. Next 22B, right? Consider the following statement for fused deposition molding. Okay, fused deposition molding means it's basically for polymer based, where the solid, it's polymer and solid based. Means wire will be fed, and in the wire is continuously fed. You can see here, right? Continuously wire is fed into the nozzle. This is a nozzle. Continuously wire is fed, and in the nozzle there will be heating. So this polymer will get melted, and it will be depositing as per the, and the nozzle will be moving as per the tool path. Here, sometimes if hanging structures are there, then we'll use two, like one is for main material and another thing is used for support structure material. So this is for build material filament, and this is a zoom section, this thing, and this is for support structure. This can be easily removed with the help of some liquid, or even with the help of some mechanical force also. This support structure deposit material can be easily removed. So this is FDM. So now we'll look into the options. FDM is mainly used for polymer material. Yeah, polymer only. Yeah. Then it is based on powder bed method. No, because here solid, it is a solid based. So 2 is not the correct answer. The molten material is forced out from the printed head nozzle. Yeah, from the head nozzle, heating is happening and it is uh, forced outside. 1, 3 is correct. Use of powder as a no, you are using as a wire. So 1 and 3 is correct. So 22B is the answer. Okay, sorry. Which of the following primary variable affects the mode of metal transfer in gas metal arc welding GMW process? Which of the following primary in the sense current, voltage, and arc gap. So 1, 3. These are other shielding gas, composition of electrode, all secondary. Discuss this. C. Yeah, 23C is the answer. Which of the following more tiny droplet rapidly? I think you guys can easily answer. Even I showed the video. It's the spray transfer. 24A is the answer. I was expecting. Arrange the required welding current to form the droplet for different metal transfer modes in descending order. Descending order is from highest to lowest, right? So spray will be more than globular and then short circuiting. Then cold metal. So so 25A is the answer. No, globular current is more than short circuit. In globular current is more though, but arc length is more than the short circuit. So A is the answer, 25A. Then which of the following statement is correct about the droplet detachment in globular mode of metal transfer? Uh, First question, if you guys want, for the sake of clarity, I can again show the video of that thing. That's why initially only I showed the video. Okay, see, a draw like current will be medium in between spray and short circuiting, and the droplet is more than the droplet forms, and it's once the gravitational force is more, then only it is detaching. That is globular, and this is the molten pool. This is the electrode. This is the droplet. Spray mode, tiny droplets, but current is more. In globular, current is in between. This is the molten pool, and this is the electrode, and this is the arc form. These and all are captured in high-speed arc images. This is short circuiting. Current is increased during the short circuiting, though the heat input is less, but current is increased. So comparatively, in short circuit, like compared to CMT, here like in spray, heat input will be more. Okay. I think we were in 24th question. 24th or 25th, I don't remember exactly. Yeah, tiny droplets, 24A is the answer. Descending order in the sense spray transfer, globular, and short circuiting transfer. Which of the following statement is correct about droplet detachment in globular mode of metal transfer? In globular mode, like gravitational force should be more than the surface tension force. Yeah, first one is wrong because they have given gravitational should be less than the surface tension force. Then there won't be any detachment, right? So gravitational force should be more than the surface tension force. 2 is correct. Then droplet transfer occurs when the size of droplet is greater than the diameter of the electrode. Yeah, 3 is also correct. 2 and 3 is correct. Gravitational should be less than the no. Basically 2 and 3 are correct. Buoyancy force we can't comment. So 24D is the answer. 26D is the answer. Then which of the following additive manufacturing technology is not suitable for producing 3D metallic components? The stereolithographic apparatus are just now I have shown this thing. Basically, photopolymer resin is there. Means polymer thing. This digital light processing and all, and other things are used for metal thing. Which of the following additive manufacturing technologies is not suitable for producing 3D metallic components? Selective laser melting, yeah, it's used. Direct energy deposition means it can be like powder based, like laser based, electron beam based, or even wire arc additive manufacturing is also comes under the category of uh, direct energy deposition process. So those are on metal product 3D printing, right? So electron beam melting also, where instead of this is also metal 3D printing. So 28C is the answer. So basically the photopolymer resin. I think this is the first stereolithographic apparatus. This is the first 3D printing, commercial 3D printing available in the market in the additive manufacturing techniques. Choose the correct sequence for producing the 3D metallic components using additive manufacturing technology. Yeah, simple. CAD model will be there. Yeah, CAD model will be there. Once the CAD model is there, it is converted to STL file. After conversion of STL file, again I am repeating for your understanding. CAD model is converted to STL file, and then STL file is fed to the AM software. Fed to the AM software. In AM software, based on the design of based on design and additive manufacturing principles, it is reoriented and sliced. Once the slicing is done, tool path tool path is generated. The tool path is generated is fed to the deposition robo or 3D printer. There feedstock will be there and also heat source will be there. Based on the tool paths, the layer by layer deposition will be there, and finally completed product needs to be post processed. So this is the process chain. So I think in 29th question, charging is not there. Sorry for the interruption. Okay. So basically CAD modeling, then slicing means once we send it to the AM software, slicing will happen, then building will happen, then post processing. So 29A is the thing. One of the advantages of this thing is like if I want to deposit two spheres of diameter, I'm giving crude example, two spheres of diameter 10 mm and 20 mm. Suppose if my conventional manufacturing is casting, so what I need to do, I need to change the mold accordingly, right? Means part specific tooling is there, but in additive manufacturing there is no part specific tooling, because here we are doing CAD model, and CAD model based on the slice information it is fed to the 3D printer. The 3D printer will remain same, so there is no uh, part specific tooling. There is no other advantage of additive manufacturing. However, metal additive manufacturing needs to be further developed to commercialize. Only right now mostly metal powder based thing is commercialized, and this GMW based wire arc manufacturing and other wire based are still in research and needs to be commercialized. If it is done also, then it will be useful for aerospace applications where large components need deposition with medium complexity depositing for using a highly cost materials like titanium Ti 6 component like titanium 6 aluminum 4 vanadium, those things which is very costly but it's used in aerospace. And also few components made from the wire carton manufacturing also used. I will show in one next slide. Okay, so 29A is the answer. Which of the following statement is correct about the direct metal deposition process? Basically, it's like direct metal powder deposition process. It is based on the powder bed method. Powder bed method means powder will be there, then powder will be there. But direct deposition means powder will be fed along with the power source. Uh, Powder bed method means powder will be there with the help of roller. Like after each deposition, the platform will be down and new fresh layer of powder will be spread from the roller. But in powder, direct deposition process, direct energy deposition process, powder also spider or wire will fed from the uh, uh, other nozzle, and heat source will be there, and deposition will be happening. So it is not based on the powder bed. Metal powder is fed through the nozzle. Yeah, so is it correct? Then wastage of powder is very high as compared to the selector, but it is very less because wherever required we are feeding that there only, right? Then laser beam is used to fuse the powder. Yeah, basically even sometimes you use electron beam also, even on welding or like GMW process can also be used. But for this thing, D is the answer. Okay, I just show